Welcome back to Auto Technic, and today we're back working on the 355. And I gotta say, these things are absolutely beautiful. One of my all-time favorite cars, but I digress. Enough of that. We're not going to be working on the car today. Today's video is all about the engine. We're going to dive deep into the engine. We're going to get it torn down. We're going to work on replacing the timing belts. More importantly, I'm going to show you guys the steps, techniques, and procedures to dial in your camshaft timing. And it's safe to say, things did not go as planned. So stay tuned to see how and why we find ourselves all the way down to a short block. Hopefully you guys were following along on the last video where we separated the complete drivetrain from the body of the car. And that process wasn't too bad, didn't take all too long, and there was really nothing too fancy or technical. A couple tricks that I shared along the way, a couple special tools that I made to make it a lot easier. But all in all, it wasn't too bad. It's really just a matter of unbolting things, disconnecting the wiring harnesses, dropping fluids, and boom, you have the whole engine out and great access. On the other hand, today's video is going to be much more technical. Replacing timing belts on, I would say, any Ferrari is substantially different than any other car I've worked on. You know, most cars you throw a timing belt on, it's quick and easy, down and dirty. You have a pretty simple tensioner system, a couple marks you line up, maybe you have to remove some covers, maybe an engine mount, a couple accessories, not a big deal. However, on these cars, it's wildly different. Even down from tensioning the timing belt and our timing marks, which they kind of exist, kind of don't exist, which is going to make us degree in the camshafts. All of that, which I'm going to show to you guys today. So let's start diving into it. So to kick things off, we're just going to start with getting this oil tank out of the way. Fortunately, there's only one line right here on the inside that needs to come off. They'll let us fully remove the oil tank. It's just sitting on the subframe with a small little pin. And hopefully we don't get a heap of oil out of here. There we go. And get coolant hose off. That will be in our way. Frequently during the timing belt services, I will remove the fuel injectors from the car. I will send them out to an injector specialist, have them cleaned and flow tested to ensure that everything is still good and that they're within specifications. Now, in order to remove the fuel rail and injectors, that requires you to remove the plenums. Now, I can leave the plenums on the car. I'll still be able to get the valve covers removed. I'll be able to do all my work on the timing belts and get everything degreed in. It just makes space a little bit tighter. However, the plenums are quick and easy to get off. It gives me a little bit more space, which is good for me. The other benefit is it's going to give you guys a lot more visibility to see what I'm doing, so that is a big perk. But also, the last thing is I have something pretty cool going on next week. And well, frankly, if the plenums are off the engine, it's going to be a lot cooler. So let's take a couple extra minutes and get these plenums off and out of the way. So the plenums are actually pretty easy to get off. Right now I'm just disconnecting the fuel injectors, and they are numbered, so I don't have to worry about the location. But that makes it easier because there's a couple vacuum lines and just crankcase vent lines under here that I need to pop off. And just getting the fuel injector harness out of the way gives me a little bit more room to pop these off. You can see I pop them off the throttle bodies first, and then they come off the plenum. And that really opens a lot of space up for me. And get this last vacuum line here. And we have a vacuum line that's splitting, so we'll have to replace that. And one quick disconnect here. And that is all the connections on the outside. So you can see, very quick and easy. Now the last thing I need to do to get these plenums off is address the clamps that hold them onto the throttle bodies. Well, I was about to pop off the hardware on the inside of the plenums to get them off, and I just ran into a prime example of why these cars are so tricky to work on, and really, you really have to know your way around them because weird things happen and they can come back to bite you in the butt. Now, what I found here kind of relates to one thing that the customer did mention to me, and he mentioned that a couple of times he had his throttle stick on him. And I do know that the orientation of the clamps that hold the bottom of the plenums on is critical, that you place them properly so they clear the throttle linkage. Well, sure enough, I found a problem. Now, what I found is pretty common, and I know of it because, honestly, I've done it myself. But before we show you that, here's what secures the plenums to the ITBs. There's a rubber grommet or hose that you can't see that's back behind there. And there's a clamshell. It just wraps around. There's two pieces on each one. That clamshell is held in place with the hose clamp. And you'll notice that all the bolts for the hose clamps are oriented at an angle here towards the center of the valley of the engine, towards the rear. And that is traditionally how they are angled when we're working on the car, especially if you're trying to take these plenums on or off inside the car. Now, the problem with that is, if you orientate specifically that bolt for this clamp on cylinder 3, well, this is our adjustment screw to balance our throttles. And as I open our throttles, you can see right there that it's hitting. And I know that that's hitting, which it should not be, so we're not actually hitting the throttle stop of the throttle. The linkage is stopping on our hose clamp, which is not ideal. Now, when I learned this lesson the hard way, I actually had a sticking throttle. Now, I've been playing with this one for a little bit, and I've not been able to get the throttle stick like the customer's complaint, so I don't know if that's a cause of that. However, I'm pretty certain that we're limited on throttle travel, and he was not getting 100% of his throttle travel when we open this up. I'm kind of going to get the camera in there, and if we look at that lower bolt on that arm to that boss, it looks like that center line of that bolt is right to the edge of the boss, so that's kind of a mental note that I'll make. I think we'll spin that clamp, rotate it, and see if we can open this throttle more, and that will tell us if indeed that throttle was not opening up all the way. I did notice on the other side, which is encouraging, on the other one, they have that one oriented correctly, so you can see that nut completely clears it. So it's on these rear throttles, or not rear, I should say, the second to the last on the back bank. This one would be cylinder 6, the other side cylinder 3. They need to be oriented different than the rest of them, so that way they don't interfere with the throttle. Alright, here's the deal. I loosened the clamp and just spun it over so it's out of the way, and that's going to let me move the throttle all the way to full throttle and on its stop. Looking at my mark on the bolt, I gained a little bit. I was about right there beforehand, right there. So power-wise, we're not going to see a difference, but at least now we caught that, and when we put it back together, we'll be sure to orient these correctly, so that way we don't have any risk of getting that throttle stuck wide open. So we're just gonna seize opportunity here and cover up our throttle bodies on top and ensure that nothing falls down and gets in there, even though the throttle blades are shut. And also, we're going to plug the holes where the fuel injectors were. Once again, we don't want anything to fall in. We want to keep the inside of the engine clean. So we'll take just a minute. Good precautionary measure. So now, I am just working to get the fuel injector harness out of my way. Ooh, lost the cover. Which will aid the removal of the valve cover. I don't really want to be fighting the harness, so we just kind of tuck it into the valley where we won't be working and give ourselves a little bit more access. We'll get our crankcase breather lines off. We'll take off our feed line for our idle valve. And while we're back here, I'm going to remove these valves, the non-return valves for the secondary air. Again, just the free room up. It's real simple, quick and easy. Plus, added benefit, it's going to allow me to function test these valves. We'll pop off our non-return valves here at the manifold. It's quick and easy. It gets them out of the way, but we can function test them. Once I get this spun off. Now, the function test these, I want to be sure that air can travel in this way, but it cannot go back out that way. Down and dirty, simple. I just use my mouth. That one's working, sealed tight. Now, if these valves are the fail, it can allow the exhaust to backfeed into your secondary air pump when it's not running and eventually burn out the pump. So we're here, might as well check them. They do fail semi-often. It's always good to know. And they're both good. They don't taste good though. Alright, it's looking pretty good. Our access looks so much better now that we got the plenums off. Moved our wire harnesses, got the spark plug wires out, and you can tell that with a couple minutes, minimum effort, it really wasn't too much work to get all this off. We have all the room and space that we'll need, and it's really going to help us out. So now it's time to shift our attention to the front of the engine. Now there's no easy way to get this harness off the engine, so it's going to stay on. I will pop a couple of these P-clamps off, and that's going to allow me to get the harness away from the front of the engine and draped over the back side, because all of our work and attention is going to be focused here in the front, and I do not want to be working around this harness. So we'll take the minute, make it a little bit easier on ourselves in the long run, and get it moved out of the way. Okay, so the wire harness is moved out of the way, and we have all the access that we're going to need here at the front of the engine. I wanted to take a minute and talk about our accessory belts here for a second. Now, typically, I never take these off and reinstall them. Anytime these belts come off, new ones go on. That is part of the service, so we will be replacing them. But I did want to take a second and show you guys that these ones are just far too loose, because when these are tensioned properly, you do not have that much deflection on them. It's actually pretty impressive how tight these are. I've never really actually seen any other manufacturers run their belts as tight as Ferrari does. And, well, these ones are wildly loose. So, when we put the new belts on, we do measure the tension with a tension gauge. This car calls out specifically for this gauge. It's a Stager gauge. It's a German-built gauge. And the only manufacturers I'm aware of that use it is Porsche and Ferrari. Now, a piece of interesting trivia on these gauges is there is no units of measurement on the gauge readout dial. If you read all the publications from Ferrari, they don't tell you what the unit of measurement is. Porsche, they don't tell you what the unit of measurement is. Steger, they're not around anymore, so you don't really know what the unit of measurement is. So I guess we'll just call them Stegers. It's, you know, Ferrari gives us a specification. We're looking at 120 on the water pump and alternator belt and 115 on the AC compressor belt. The power steering pump belt is so short we physically can't get one on, but I'll show you. I have another tool that we can use to get that tension dialed in. So since we have the tool and we're here, we know these are too loose, but let's just see how far they are too loose. And this one's reading 70, it's supposed to be 120, so substantially loose, which we figured. And on the AC compressor, this one's supposed to be 115, and we're reading 55. So again, really just kind of trivial knowledge. It's nice to have. I'm going to document it and note it down. Now these belts probably did loosen up over time with some running, but to have them be this loose even on disassembly, I've seen enough cars come through that I'm pretty confident to say that these belts were too loose on the initial assembly of the car. Either way, they lasted. The client didn't have any issues with it. It all worked out in the end, but we will get them back to the proper specs on reassembly. All right, we're to the point of the job where this gets unique and specific to Ferrari. I think, vaguely speaking, for most all manufacturers, at least for me, every other timing belt job that I've done to a car, this is about as far as you need to go. We have access to our timing belts. We would rotate the engine over to line up our marks on the crankshaft and our marks on our camshafts. Maybe use some tools to lock those in, pop our tensioner off, replace our belt, and move on with our lives. However, one of the big differences on a Ferrari versus any other car, there is no external marks to locate our crankshaft or our camshaft position. We have no idea where they need to be and where they are in relation to the engine cycle. Now in the Ferrari world, you'll hear the term belt slap quite frequently, and what that is referring to is when someone is going into a timing belt change, say on this 355, they only take the engine down to this point. They'll maybe clamp these gears together. I've even seen people use vice grips, clamp those cam gears together so they don't move, pop the timing belt off, put the new timing belt on, set their tension, maybe, take their vice grips off, reassemble the car, send it on down the road. That's what I was discussing in my previous video, where some people say you can do timing belts in a 355 with the engine in the car by removing the fuel tank. But I'm going to show you here in a little bit later, in order to get the cam timing set properly, that's not really possible. Since we don't have any assembly or install marks to locate our camshaft and crankshaft for the timing belt job, we're going to have to physically measure where our crankshaft is at and where each camshaft is at in relation to the crankshaft. And the only way to do that is to get the valve covers off of the engine and access to the camshafts. Now, removal of our valve covers or cam covers, whichever you choose to call them, is actually very straightforward at this point. We just have a couple perimeter bolts to pop them off. These aluminum plates with our cam seals actually stay on the camshafts. In order to get the valve covers off, on the left side over here, we do have a vacuum pump, and that supplies a vacuum for a brake booster. That needs to come off the back side because it's bolted into the cam cover, and the cylinder head. And on the right side, instead of a vacuum pump right here, we have our lone crank sensor with its housing. Again, same thing. This housing is bolted into the cylinder head and the valve cover, so we're just going to remove that entire assembly, get it out of the way, and take our perimeter bolts off, and we'll be able to lift the valve cover off the engine and have access to our camshafts. But before we do so, I wanted to come back and readdress something I covered on my inspection video, because now we have great access and it's right there. So if you can see that right there, that is our valve cover gasket, which actually has pushed out. So that gasket should be running flush right here. Move you right there. And that should be pushed in and equal to where the valve cover ends. This is actually a very common occurrence on a lot of the Ferraris of this era. It's really not a great design because it's a paper gasket, and essentially this is sealed up with one piece of paper across the bottom, and then it transitions to an O-ring across the top, a small piece of paper up here, there's an O-ring up there. All in all, I've counted it, and there's like 14 or 16 different gaskets that are used to seal this valve cover. I'll show you when it's off. It's not the best design. But I say this as in, this is just a long, skinny rail all the way across the bottom. And there's nothing attaching this edge of this gasket up towards the top of the valve cover. It ends right there. And this bolt is so far back from the back side that these gaskets have a tendency to push out exactly as this one is done. Now, this isn't, huge or critical. It just causes a little bit of an oil leak. You can see it's all dirty back there. On the left side, that one pushed out as well, and it was actually dripping oil back on the cylinder head. And that's wildly common. Valve cover leaks on these cars is actually pretty typical. We have it from the valve cover pushing out. We also have issues with the O-rings on these cam plates up here. They get pinched and torn, and they will leak as well. It's good to follow the 3-year service cycle on the timing belts. That is Ferrari's recommendation, because generally speaking, your valve cover gaskets are going to start to be pushing out and seeping after that 3-year point. So it's good to stay on schedule to replace your timing belts, because it really also gets your valve covers sealed back up and prevents these leaks. Now, I do have a couple techniques that I will share with you guys on reassembly on different ways we can prevent this from pushing out. So there's, our sequence of assembly, which is important, but also a couple tricks that we'll do. There's also a few more tricks that we'll do up here for the O-rings to prevent those from getting cut and torn. Again, just another area where these cars are unique. Most manufacturers will run one gasket around the perimeter, say a nice O-ring. Getting these valve covers on so they don't leak, the gaskets don't push out, and they seal up nicely takes a little bit of time. With that being said, I'm popping off my cam sensor, vacuum pump. We're going to get the valve covers off and out of the way and see what these camshafts look like. And we'll just leave the cam sensor in. Taking a little magnet here and getting all of the washers off. It's much easier to take them off now versus trying to lift the valve cover off, having them all fall and not know where they ended up. So this way I can get them all off and account for all of them. Okay, so the valve cover is actually going to be on pretty tight with a combination of the paper gasket that's holding it on and all the sealant. Since we have the vacuum pump off the back, I'll have just a little bit of room to get back there with a small pry bar. I need to get this off of the head just enough to where I can work the rest of the edges around the perimeter to get it driven off. It also is a little bit tougher since all of the mounting hardware is actually studs, so we have to get the valve cover to slide up and off those studs. And as you'll see, once it starts to come off up here on the front plate with the O-ring, those kind of help retain it in. So it's really, really hard to do that unless you give it a little bit of a head start and just gently pop it up. And got just enough there where I can switch and gently work this up. And you want to be careful when you're doing this that we don't end up damaging or denting the sealing surface on the head or the valve cover. So we're just carefully working it. Sometimes these things can get pretty glued on there. There we go. I think that'll do it. There we go. And most of our valve cover gaskets stayed on here. We'll pop that off. And get this upper one off. And this rear plate, I should be able to pull that out. If not, same thing. The sealant is locking that in. We'll gently pull up on that and we'll break that sealant. There we go. So this one's a little bit tighter to get off because the sealant up here on the front plates was really holding it down. So it just took a little bit more work to get this one freed up. But I think we're in the home stretch now. There we go. Ooh. How lucky are we? That is very rare. But we got that off without tearing our valve cover gaskets. That's excellent. I will leave those on right now. Actually, I'm going to leave that on as well. I'm going to leave those on. I'll drop you guys in and I can kind of show you how these gaskets are, especially on this back one, on why it pushed out. Now, we're super fortunate that we didn't tear any of this green paper gasket. That's actually pretty uncommon to get a cam cover off without tearing these. And the fact that they're all fully intact makes this perfect to show you the issues with these gaskets and what happens. Now, specifically what we're looking at back here is where this gasket pushed out. And you can see right there, that big gap where we have the aluminum head and this gasket pushed out. Maybe it's a little bit more than 1/8 of an inch. See if I can lift it up with my little pick here without tearing it. So you can see real clear how it has slid out. And now that you can see with everything apart, there's really nothing there other than the squeezing pressure of the cam cover to the head to keep that gasket in place. And so then that slides out and it leaves that large void from that O-ring, and that's where that oil leak and seep is. Again, it's not a great design because this gasket runs and it does the same thing up here at the front where this cam plate is sealed with an O-ring and we have that junction there. Up top, same thing, but it's even worse because this piece is just a little piece by itself tucked up in there. So we have all these junction points with the O-rings, same thing up top, where those are all the problem areas where they leak. It's really twofold. The problem is the stud is so far back to the edge of this gasket and there's nothing else to keep it there. They push out. And it's also the fact that there's a transition for an O-ring to the paper gaskets that make this the problem. So it's just not this paper gasket to O-ring interface and where they push out that's the problem with sealing these cars up. If you look at this cam plate, and this one happens to come off of the left side, you can see that that O-ring, get you guys close, is just chewed up, it's split, and it's torn. That is very typical, very common, and that happens on installation. Essentially, your valve cover and the cylinder head are biting into that O-ring so much that it's splitting it and cutting it. So if you have this happen at that junction and you push a gasket out, there's really no chance that you're going to seal these gaskets up. I mentioned earlier that there's a whole lot of gaskets on here to seal this up. There's 14 in total. I'm counting each section of the paper gasket as its own gasket, so that's 4 gaskets of our paper gaskets there. There's these small O-rings up here for the spark plug tubes. That puts us at 8 gaskets. We have 2 O-rings up here for the cam plates, plus our camshaft seals, an O-ring back for the rear plate, and then we have another paper gasket similar to this green one for the back cam cover. All of that adds up to 14 gaskets. Now, the front cam seals don't interface with the other gaskets, so that leaves 12 gaskets essentially for the valve cover that all interface with each other and have to be sealed up. Now, typically most cars just use a rubber perimeter gasket to seal up the valve cover, maybe with a couple rubber gaskets for the spark plugs if they go through the valve cover, and some rubber grommets for the bolts, and that is it. You can tell that this system is wildly different, and there is a lot of tribal knowledge, tips and tricks that I have for you guys on how to get these installed, sealed up, so that way they don't push out, you don't pinch O-rings, and you won't have oil leaks. We're not really going to dive too deep into that now. We're going to wait till our new timing belts are installed into the engine. We're putting the valve covers back on, and I'll show you guys all of those techniques. Okay, so we got the engine torn all the way down to the timing belts. However, we're not just going to go and tear the timing belts off and get the new ones on. Before we take them off, we're going to run through the cam timing procedure. So I'm going to put my degree wheel on the crankshaft, all my dial indicators up on the engine. I'm going to run the engine through. I'm going to go through the full procedure. I'm not going to change the cam timing. I'm only going to be measuring where it was at when the engine arrived. We're going to get all that documented down. Once we have that, that is the point where I can move in to getting the cam belts off. However, I do need to take a slight pivot from that also. It's a separate repair that's not associated with the timing belt, but there's the gearbox oil cooler in the valley of the engine. The rubber boots have swollen to the point when we did our inspection, we found that it actually pushed a hose clamp off, and I can't properly fit those hose clamps on anymore. So we're going to replace those rubber boots. The easiest way to replace those boots is to remove the water pump housing from the front of the engine. So the water pump with the entire housing, thermostat, and power steering pump is all going to come off the front. Now, I'm doing this now because when I pull that assembly off the front of the engine, I'm going to drain the top end of the block. All of that coolant will end up running down the front of the engine. And on these timing belts, you cannot get any coolant or oil on them. So we're going to do that now because it does not matter on these old timing belts. We're not going to reuse them. It doesn't matter if we contaminate them. But we don't want to do that repair on the other side with the new timing belts. So I'm going to seize the opportunity and get that off now. So my plan is just to really quickly knock out the cam timing check. I'm not going to walk you guys through that because we're going to cover it in great detail on the reassembly of the engine. I'm going to get that water pump housing off, and then we'll be down to the bare block and ready to get into the actual replacement of the timing belts. So we ran through the timing check on all 4 camshafts, and to my surprise, both banks pretty much dialed in. Maybe a degree off before or after top dead center, which is pretty much our tolerance. So it doesn't really give me that info that I was expecting to see on the difference that we had on cranking compression from bank to bank. However, I don't have a good explanation for the compression difference between the 2 banks. I will relay this information to the client. The only thing that we have that's an outlier is the spread on the compression test. Although it's a little bit more than we like, I would love to be able to explain it, but right now, don't have a good answer on it. So we have the engine all ready to go for the final teardown to get the timing belts off, get our cam plates out, cam seals, O-rings all replaced. However, we need to pause and stop right here, right where we're at. Now, if you remember back when I was talking about taking the plenums off, I mentioned I have something pretty cool coming up. Well, I have some special guests coming to the shop next week. We're working on a couple really cool projects, and frankly, I need this engine in the exact state that it's in right now. I don't want to go any further and do any more disassembly. We're going to stop working on the engine today. I'm going to take a couple minutes and get the shop cleaned up, but don't worry guys, I'll bring you right back once we're done, and we'll continue on getting the timing belts installed and agreed onto the engine. Well guys, it has been about 2 weeks since I've been able to come out here and get any work done on the 355, and here we are now, and I'm pulling the exhaust manifold off the engine. So let me get this exhaust manifold off, and then I'll grab you guys, we'll go to the bench, and I'll explain to you why we're digging deeper. As you guys can see, these nuts for this manifold are actually pretty tight to get to. Bottom row wasn't too bad, just a long extension with the universal joint, and could pop them off. However, up here on the top side, you can see that we're limited to a flex head 1/4 inch ratchet, and I got to work around the secondary air injection pipe and kind of dip down in there. It's pretty tight, and thankfully on this car, these nuts are spinning off very nicely. It's really a best case scenario on these ones. I'm breaking them free at the ratchet and I can spin them off with my hands. On the ones where that's not the case, this turns out being quite a bit of a fight. Just not a lot of space and accessibility. Obviously a lot easier with the engine out. I have done these with the engine in the car and it's much worse, but it's manageable. And we're on the last one here. I also have left the catalytic converter on the back end of the manifold. I'm hopeful that I can get it out with leaving it on. The reason why I want to do so is because that's going to have a big effect on my exhaust adjustment, and this exhaust and the tailpipes, the way they fit in the bumper before I pulled it apart was excellent, and sometimes that can be a bit of a pain and I don't really want to go through it again. So if I'm able to sneak this out as a unit, I think that will be a win. And I have never tried to do so. And I think we can do it. Just gotta pop my O2 sensors off. Now let's see if we can't get this guy out of here. Get that lifted up. Yeah. Take off our heat shield for the axle boot. That's got to come off anyways because we're going to have to be replacing our CV boots. Okay, let's see if we can't ease this out. So close. Now the cat is the problem. And our wire harness is the problem. Take that wire harness out of the way. This is starting to become a lot more work than I anticipated. Hard to say if this is going to be beneficial in the end. I mean, I guess it's going to save me time on the exhaust adjustment. And it's only a couple extra things we've taken off. Hard to say. Give and take. We'll see if it comes out with this harness out of the way. Can I sneak that cat out? So close. Oh, got it! Well, despite the gash on the hand, I think that was a win. We'll get our gaskets off, and then I'm gonna take you guys up to the bench and discuss what in the world we're doing over here now. All right, so here's the deal. We all know that I don't need to pull the exhaust manifolds to do the timing belt service on this car. There's another reason why they're coming off, and it all comes back to that compression test. Really, the down and dirty of it is, we've got to pull the heads. This car needs valve job, possibly valve guides. And the way this came about is when I was speaking to the client, giving him an update where I was last week, I was just kind of talking him through to where I found the cam timing to be at versus where I expected it, and I really expected the cam timing to be the cause of the difference of compression from bank to bank. Essentially, the compression was unbalanced. Well, as I was running him through that, I realized I have my degree wheel on the engine, so I already know where top dead center is. I know the firing order of the engine. It would be foolish of me to not run in and do a leak down test. It's only going to take a matter of minutes to get it done with the engine out of the car and full access to it. And well, lo and behold, ran that leak down test and unfortunately found the answers to the unbalanced compression. It's not what we wanted to find. On bank 1, I have 10% more leak down on each cylinder as opposed to bank 2. Bank 1 is the side of the engine that has low compression, and I can audibly hear all the leak down coming out of mainly the exhaust valves, with exception to cylinder 5. It's coming out of the intake valve pretty heavily. You can really hear the air ripping past it when you open and close the throttle. It's a pretty substantial leak. Now I'll take you over to our paperwork from our pre-service inspections that we did in a prior video and really walk you through this because a lot of this evidence really supports what we found. So we have right here a compression, cylinders 1, 2, 3, and 4, that's bank 1, 200, 200, 205, 190. Bank 2, across the board, is all at 200. So I have everything banked up here, so this is the front of the engine. That's how the cylinders are numbered out. And you can see that bank 1, 200, 200, 205, 190. Same thing on bank 2. You can see right here is our leak down results. So we're running about 10 to 11% with the exception of number 5. That's the only thing that's, I would say, abnormal in this situation. That's the cylinder that's leaking out of the intake valves quite a bit, and it has a little bit more leak down. However, our compression was still decent on that cylinder, and I attribute all that to the fact that it's leaking out the intake valve, not the exhaust valves. Everything on bank 1 is leaking out the exhaust valves. And you can see that our leak down percentage roughly matches our lower compression, meaning our 205, which is our stronger cylinder, it has less leak down. Our cylinder with the least compression has the most leak down. Now we can kind of jump further back to when I did the pre-service emissions test. So really what we're looking at here is our hydrocarbons. So if you see at bank 1 idle, I'm at 170 parts per million, bank 2 114. Again, not a big difference, but there is a difference bank to bank. At 3,000 RPM, I'm at 229 versus 81. Again, a minor difference, but there is a difference. And I did notice all this when I did this test, but they're not a big enough spread for me to be overly concerned. Now on our NOx, we're at 90 parts per million, 109. Again, bank 1 lower. At elevated RPM, same thing, 104 versus 136. If we have less compression on cylinder 1, we have less cylinder pressure. Less cylinder pressure, we have less cylinder heat, so our NOx is going to be lower. Our NOx is lower on bank 1 versus bank 2. So right here, telltale sign, there's an imbalance and something's not dead set exactly right. We do our compression test again. These numbers weren't radically off, and the fact that they were kind of paired bank to bank was unusual rather than just having one hole that was an outlier. That was a little bit of a red flag, which took us to our leak down test, and that gave us all the information, and compiling all 3 of those things together really gives us all the information we need to know with the physical evidence of hearing the air leak out of the exhaust valves through the exhaust and the intake. Tells me everything I need to know they're really confirmed that at least our valve job is gone, but more than likely when the valve job goes, that's a valve guide issue. So I have updated the client with that. I talked him through it, and we have made the decision to seize the opportunity. I mean, we're halfway there doing it with the belt service, so the additional labor is not that much more. They get the heads pulled off. We're going to get them sent out into my machine shop, and the machine shop's going to go through, check our valve guides, check our valves for wear, springs, do a full rebuild on the heads, and once they're back, we're going to get them back onto the engine. So with that being said, that's why we're pulling the exhaust manifolds off, because, you know, we got to kind of deviate a little bit from the belt service and get the heads off this engine. So I'm going to work to continue to get the bank 1 manifold off. You can see over here where I peeled that wire harness off. So just 2 bolts there. I can get that wire harness up, spin you guys around. I'll work to get that heat shield off. That's pretty easy versus that side. Take my O2 sensors out. I did kind of decide that it is easier to do that. A little bit more disassembly, but the fact that I don't have to mess with these springs and this exhaust clamp and hopefully have to readjust my muffler, I think it's worth it. Manifold coming off. All right, bottom row is off nice and clean. Let's see if I can do the top row without destroying my hand like I did on the other side. I think I'm just going to go through and loosen them all up first. Ooh. Oof. Not a lot of working room here, not even for a 1/4 inch ratchet. But fortunately, once these get loose, they spin off pretty easily. So it's just a matter of breaking torque. It's really this rail right here that's really complicating this. Let's see if I can't barely get in there. This rear one. And our last one, just zip that guy right off. These all came off very cleanly. Quite a nice little treat. And we'll see if we can work this exhaust off and get that cap past the head. Just kind of, we have, I can see the starter back there is gonna give us a little bit more an issue. There we go. Can we get it? Oh, golden. Sweet. So with any 355 that I have come in the shop, especially if I've never seen the car before, such as this one, there's really 3 things that I worry about the most on them. One of those being exhaust manifolds. If it has a cracked and failed exhaust manifold, that's why we run through and do that smoke test that we did on our pre-service inspection. The other one is the catalytic converters. Again, checking the honeycombs for those and being sure that they haven't failed or starting to fail. And the last one's the valve guides, such as we found on this one. Now, the reason why they're really my biggest worrying point is because all 3 of those repairs are incredibly expensive, and it really drives the cost of the service up quite a bit. And honestly, I don't want the clients to have to go through that. I really want their ownership experience to be pretty great with minimal money put into servicing and maintaining the car. And it's just really unfortunate when these ones come across, but there's not a lot we can do about it. And I'm fortunate enough that this customer wants to fix it and make it right, and gave us the go-ahead to do the repairs. Get that washer off. Woo! There we go. Get that linkage off there. All right. Now, when I first started with Ferrari, it was back in 2012, and it really seemed during that time when we had a 355 come in for a belt service, it wasn't that frequent that we found one with bad valve guides. Now, there's the initial rush of cars that had bad valve guides before they got the updated ones that Ferrari had. And looking back on it, after finding this one, I kind of went back and looked at some of my records that I kept on the cars that I've worked on, and it seems that all of the later cars that I've worked on in the past recent years, it's becoming more and more common to find the bad valve guides. And it's not just on the earlier cars with the earlier bronze valve guides, it's even on the later ones that have the sintered metal ones like what we have here. And I think it's just really a matter of time and age. As these cars are getting older, it's just becoming more and more prominent and continuing to be a bigger issue. So now we got to get the wire harness unbolted from our throttles. Get these little bolts off. And again, get our washer so we don't drop it. And just slide everything right back on. All right, pull our wires for the injectors through. Now, fortunately, these are numbered, so we don't have to worry about which one goes where. But there is some connectors back here that will fit multiple things, so we do need to mark them so we're sure to get them back into the right location. Take that vacuum line off, and I think with just that, now we're ready to get the bolts loose and get these throttles off over here on bank 2. There we go. Ooh, close. So just getting all these nuts off for the throttles, and with everything else on this car, there's washers up underneath of it, so we'll have to come back with our magnet and pick those washers up so we don't end up dropping them. Move my throttle linkage, get a straighter shot on this one. There we go. And on to the last one. Get all of our washers off. And should be ready. There we go. Work on getting bank 1 off, and our wire harness, just this one bolt back here. I've already done the front one. So these connectors here are the ones that will also plug into where our cam sensors go. It's pretty easy to see, and I did take some pictures, but we'll just throw some yellow tape on these guys for good measure, just so we know that these are our throttle connectors, and we don't end up chasing our tail with some weird issues on the other end of the repairs here. This one's pretty tight. Get that off. And now the wire harness needs to move over. Coolant temp sensor coming out. Give me some more room. There we go. Injector wire harness coming through. Injector harness off back there. Get our valve cover gaskets off. Still haven't pulled those off yet. And bank one coming off. There we go. All right, with the throttles off, I'm able to move the wire harness to the sides, and we have a clear view at our coolant manifold and our gearbox oil cooler. Now, if you recall in my initial inspection, this rear hose clamp back here had actually slid off this boot because it was deformed so much. That's why it has this other bolt in there. I needed a little bit of a longer bolt to get it back on so we can run some coolant pressure tests. Well, we're going to be replacing those boots. That was planned separate of this headwork, so we're just going to take those off now. We're going to leave the gearbox oil cooler in the valley of the engine. There's some braided AN lines off to the side, and I don't want to mess with taking those off. But we will just pop both boots off. We're already here, and the small silver lining of this is overlapping labor. So the customer approved the replacement of these boots, and then we unfortunately found out that it needed the headwork. So that pretty much put the labor to replace these boots to a net zero, and a little bit of coolant in there. So it made it not as painful. Slide this. Let's see if I can't get this boot off back here. Might need to get that. There we go. I'll let that sit there. Get this top one off first. It's loose. We will probably wait and get the side pipes here loose. And that's going to give me more play to get that top one off. It's all pretty tight. See if we can't expedite this a little. And once again, all of our washers. Come on, little guy. Washers are off. comes off. There we go. And actually it all wants to come out as one unit. I don't think I'm gonna get it as one unit, am I? There we go. All right. Set our wire harness back down where it kind of wants to lay. All right, well now it's time to focus our attention to the front of the engine. All right, so we have the engine sitting on top dead center, cylinder 1 compression, so we're good to pull all of this tooling off from my degree wheel, and that's going to give us access to our timing belts because that's the next thing to come off. So you guys will notice my degree wheel here, I actually have it bolted into the front crank pulley or the harmonic balancer. This is not the one off the car. I actually have a spare that I sacrificed for this purpose, and that's for a couple of reasons. One, it allows my degree wheel to be bolted to the crankshaft so I don't have to worry about slipping. A lot of times when you bolt a degree wheel with the center bolt on the crank hub and you use that bolt to rotate the engine over, your degree wheel can spin on your crankshaft and all of your cam timing's out of spec. I don't like dealing with that. I like it to be a rigid solid mount, so by bolting it to the front of the crank hub, it is splined to the crankshaft. I have zero movement. The other benefit is it traps my socket in there. I have a little spacer that holds it in, so it just makes it a lot easier tooling wise to have everything set up in there while I'm spinning the engine over to check cam timing. We'll get our bolt out. And slide our hub off. And now you can see we'll have great access for our timing belts. And also while we're in here as part of the service, we're going to replace the front crankshaft seal. So all this stuff needed to come off. And get our pointers out of the way. There's really no point in trying to work around these items. And, you know, we're undoing all the setup that I did when I initially set this up. But I have no problem going back on the end and making sure it's set up properly again, rather than trying to work around it and hoping that I don't bump it or move it. Get that washer. All right, so before we take the tensioners off and loosen up the cam belts, there is one thing that I want to show you. There's a little bit of a trick here because, well, Ferrari didn't really give us much consideration or thought on servicing these cars, so there's a little bit of a workaround. All right, this is where this setup gets a little bit funky, and it has to deal with the camshafts and getting them out of the cylinder heads. Because of these front cam plates we have right here, which are bolted in on the bottom with those two bolts, we cannot leave the cam gears on the camshafts to get the cams out of the engine. We need to pull the cam gear off, which then we can access those bolts to get this cam plate loose, and we can slide that cam plate forward and out of the head. Then we can lift the camshafts up out. However, Ferrari gave us zero provisions for locking the camshafts or the engine in place. So I've seen manufacturers that have special tools with like a dowel that goes in and locks your cams in place. I've seen hexes cast into the cams. There's crank pins I've seen that go into your flywheel or your crank hub in the block that locks everything in place. There's absolutely zero provisions on a 355, or as a matter of fact, pretty much any Ferrari up to a 488 that has a provision for locking the engine in place. We need to get these bolts loose. Sure, we're on disassembly. We can take an impact, zip these bolts out, and it's not going to be a struggle, and the engine won't rotate over. We have nothing to worry about. However, on reassembly, we're going to need to torque these, and these are torqued to 100 Newton meters without rotating the engine, and we have no way to lock the engine in place. So the solution to that is some backyard engineering, and you can see that I've taken a business card, I tear it into 4 sections, loosen the cam caps, lift them up, slide it in, and hand tighten these. It just so happens to be that the business card is the perfect thickness to take up all of our oil clearance, which essentially seizes the cams in place. Now, you can see that with each camshaft locked down in 2 places on both sides, this engine's locked tight to where I can now get a wrench on here, loosen these bolts. So it's not so critical now on disassembly. On reassembly, we're going to need to use this technique so we can torque those bolts. However, there is a side benefit because once we pull these timing belts off, we don't have to worry about the camshafts rotating and any unwanted valve movement because our business cards are holding the cams in place. So I have seen, if you put something thicker, say 2 business cards in here, I have seen someone do that. It did crack a cam cap. Also, when I tighten these down, the nuts on it, just hand tight with a small 1/4-inch ratchet. You don't need a lot, just a little bit to snug them in there. Again, we're not trying to really reef these down and tighten it. We're just trying to hold the camshafts in place. It's going to allow us to get our bolts broke free up here. We can release our tensioners and get our timing belts off the front of the engine. So with our cams locked in place, you'll see that it's locked solidly in position and able to crack those free. There we go. Now before I loosen the tension on the timing belts, there is special pins that go into this hole, and that is part of what we use to tension them. Also, it's going to prevent everything from expanding and basically overextending from here, which then we're not going to be able to get the belt off at all. These ones weren't tensioned exactly right, so you can see that I can't slide this in all the way. So I'm going to loosen it just a hair, and there's a special little tool here. We'll slide that into our tensioner, and I'm going to see if I can't make a small adjustment. There we go. So I got the pin all the way in, and with that, now I can break free this bolt all the way, and now my belt's loose and free to slide off like so. Now on this other side, I don't have a second one of those tools, so I'm just using a drill bit that is the same size. And again, I need to make a small adjustment to get it in there on my tensioner. There we go, and it slid all the way in. And now we can loosen up our tension on our belt and get those slid off like so. So with the belts off, we can just spin out the bolts that hold the cam gears on, and we're going to want to leave the cam gears on right now. We don't want to take them off because we want to make some marks on the positioning of them, and I do so just to make it a little bit easier on reassembly. It's not something that you have to do, but a lot of times it may end up saving you a little bit of time. So I'll get these out, get them worked, and I'll show you exactly what I'm talking about. Alright, so this is not a must do, but this is definitely my preferred method. You can see that I just put a 1E for bank 1 exhaust, 1I for bank 1 intake, same thing for bank 2 on our cam gears. Now I use Sharpie because when I'm done, I wipe all my marks off. I don't want any traces that I was in here and that I marked it up. Someone before me left marks up here on the teeth, and I'll wipe those when I'm done, and I don't really do that because that means very little to me. I also made a mark right here, and that's where my dowel pin sits. So each cam gear aligns to the camshaft off of a dowel pin. You can see I have a whole lot of holes going all the way around the perimeter. And right on here, the inside is my camshaft, and I used a paint pen to mark the hole that the dowel pin is going on corresponding. Now I do so because this is going to make reassembly a lot easier, because it gives us a good starting point because we knew where our cam timing was. But you can see when I pop that cam gear off that there is a lot of holes for that dowel pin. The same thing on this camshaft. It's an extremely adjustable system, and I'll cover it in a lot more detail when we're putting the timing belts on and running through the cam timing. But you can see why I just took a couple minutes and made these marks. We checked our cam timing when I was pulling this apart, so I know where it was at, and I know that if I reassemble this where those marks are on this particular car, the camshaft timing was dead on. I should be exceptionally close. Now, I do anticipate that the machinist is going to take a little bit off the head surface, so they're going to come down a little bit, so that's going to change my camshaft timing. However, given the adjustability range we have here, making my marks is going to save me a lot of time to where I'm not wildly off on my camshaft timing, and it gives me an excellent starting point. With that being said, I'm going to continue on getting the camshaft gears out, getting our cam plates off, and getting our camshafts out of the heads. And man, we are really, really close to getting these things pulled. Well, we almost got it all done last night, but we just ran out of time. I had to stop short of loosening the heads up and getting them pulled off the engine. You can see that I have all the lifters and cams, cam gears, everything out of the heads over there on the bench, and I did mark all the locations where they go, primarily the lifters. They are hydraulic, so we don't have to worry about shims and the location of them in a sense, but I always like to keep these in the exact same cam lobe that they run on, so that way there's no potential wear issues down the road. So just some simple marks, pretty redundant. I mark the lifters themselves, just number them all the way down, intake, exhaust, bank 1, bank 2. And then I set them on just some cardboard, and again, that's numbered how they're sitting in the engine. So it's a little bit of a redundant system, and we'll just get those covered up, and they'll sit and wait until we go back together. Now, as for the heads, they essentially are completely ready to come off. If you want to look, these cars use head studs, and if we look at our location of the head bolt, it is very tight. So there's a special wrench that you use to get these torqued back on. I have normal box wrenches that I modify that I use to take these off because I find it just to be a little bit easier and quicker. Now over here on the exhaust side, you can see that our head bolts are right up there. There's a little bit more space, but you can see that there's provisions right here, and that's where we have oil drain tubes. I left them on this side. So we have these tubes. Just got to pull these two Allens off. They slide out. They seal up with some O-rings, and that'll give us access to all of our head bolts. So I'm going to work to get those oil tubes off, get the rest of these head bolts broken free, and well, it's time to get the heads lifted off. All right, I think we'll just start here on the bottom row on the outside of the head. That's probably going to be a little bit worse to get to. Made it a little bit easier on myself by breaking them all free, so I can just come down here and focus on getting them off. And you can see that I think 355 probably wins the award for the most inaccessible head bolts on any car that I've ever seen. Considering what they've crammed into these heads with how amazing the intake ports are, which once we get on the bench, I'll show you guys that. 5 valves and just how small the physical package is. It's actually kind of impressive, although not easy to work on. So we're getting those off. That one's done spinning out. Are we going to be able to get that off without lifting the head? Probably not. There we go. This one's loose. Fortunately, once you get the torque broken free, these nuts are spinning off real easily. Otherwise, this would be quite the challenge. Alright, so just that guy right there. Need another bite. That one's a little tighter. There we go. See if I can't get any of those nuts out of there. Yeah, we're gonna have to lift the head to get those guys out, so we'll go to the top row. Ah. We have all of our nuts loose, and I'll see if I can fish them out. I'm gonna get the top ones out. The bottom ones are probably going to have to wait till I get the head lifted a hair. Actually, see if we can't get this head up a little bit. So our washers are holding us up. We have our nuts on our studs, but there's washers that are sitting down there, and they kind of get caught on the threads of the stud. And that's what's going to make this difficult to get this head lifted up. And I need this head lifted up so I can get these nuts out so I can get the washers free. So I think we're going to employ a little bit of leverage. Give ourselves a little bit of a head start here. There we go. And with that, it's enough to get our nuts out. Probably not on the back. We'll leave that guy. And that guy. All right, so we got all the nuts out but one. Let's see if we can't find a safe place to leverage this head off. I need to get the back lifted up. There's a boss that's cast right into it, right there. Lifting up on the gearbox. Might be able to get in there. Gonna work. Nope. See if we can't just loosen it. The problem is I can't get to the back, anywhere on the back to just get it lifted, pry off. And I don't want to pry on the deck surface. So I'm just working it here on the front, giving it lifting pressure on the rear, and seemingly making no progress. There we go. And that should do it. There we go. One cylinder head off. Pop our head gasket off here. There we go. All right, bottom bolts. Yeah, nice and easy. Come on. Switch to our 12 point. There we go. So earlier I mentioned that we had a film crew here and we did some filming for a week on this car, and that's why we had it stopped with the belts on the engine and we didn't go any further. And, well, that whole story comes back to the fact that when I graduated high school, I actually made the choice to attend Wyoming Technical Institute, or Wyotech. And it really was pivotal in my career because I initially went there to get into the hot rod industry, and I took all their hot rod programs. And I actually ended up pivoting while I was at the school and got accepted to take schooling for BMW, which put me into the world of the automotive dealerships. And that eventually led my path for Ferrari, which was a dream job. I mean, I wasn't working in the hot rod industry, but it's pretty cool working for Ferrari. And ultimately, I mean, I worked at Ferrari for nearly 10 years and competed 4 times consecutively for their competition to be the top technician in the world. They take the top 12 technicians globally and they all go to the Ferrari factory in Maranello. We all compete with one another and they announce a winner at the end of this competition. And I was fortunate to win that in 2019. And Wyotech got wind of that and we've been talking, and they wanted to come out and kind of film a little feature. They really wanted to cover my path of how I went from just a young student at Wyotech all the way through BMW and Ferrari and ultimately becoming the best Ferrari tech. So they came over, we did a lot of filming, we made, I mean, it seems like multiple different videos that we filmed for all kinds of content. Some of it's going to be on their YouTube channel, some of it's going to be on their socials. I might be sharing some of it on mine. And really, honestly, the whole experience was so radically new to me, it went by like a blur. It was just really interesting experience. You know, it's my story and I've shared it with them, but then it's somebody else's job to create it and take their creative vision telling my story. And I don't know what they have in their head and what they're going to make. So it's kind of interesting for me to see what someone else's spin is going to be on my story. So once that gets all through editing and gets posted, I'll definitely direct you guys over if you want to view that content and just hear a little bit more about my story. And for any of you younger guys out there that may be watching, if you have any questions about the School of Wyotech or any interest in it, I'd be more than happy to share that with them. I had a great experience there. I've always been extremely proud of the school, proud of my time at the school. So I'm more than happy to share my input and give any advice to anyone that's considering potentially attending the school. These ones are a little bit tighter still. And I think we have all of our head bolts loose and free. See if we can't fish a couple of those out, make it a little bit easier on us. Is that one gonna come? That guy wants to stay. Those want to stay. So we were able to get 3 of them out. Not very good. We're gonna have to get our head lifted up, much like we did the other side. I have a boss for an oil galley and this bracket right here for the tensioner. And that's gonna work nicely. So I really don't wanna, or I say don't, I won't pry on the deck surface. That's just an absolute no-go for me. So I try to find other areas where I'm not going to mark the head up, I'm not going to damage anything, but there's really no other way to get these heads free than just a little bit of leverage. So just take our time, be smart and methodical with it, and find a good area. If you guys watch all the jet boat rebuild videos, you know I'm real particular, a lot of OCD, and on these cars it's a little bit different. We're not building and creating or fabricating. You know, it's a little bit more of just R&R, removing things, reinstalling it. But I'm really picky. I don't like to leave any traces that I ever worked on it, so I don't like to leave tooling marks. I don't like to leave silicone sealant oozing out everywhere. I really want this to be pulled all the way apart, put back together, and if someone else works on it, I don't want them to know that the heads have been off and put back on. That's always my goal. So, with that being said, it takes a little bit more time to work on them because we have to find workarounds rather than just the easy, quick way to get things done. Case in point, getting this head free of the engine. So I think my best shot is off of an exhaust stud on the back and right there on the transmission. Just enough. Come back front. I think we're a little high. There we go. And head is free. All right, I'm gonna gather all my nuts and bolts, get this head gasket off, kind of get cleaned up a little bit. And there's a couple things I want to show you on the bench, the cylinder heads. I mean, these things have some absolutely incredible ports. So yeah, let me get everything tidied up here and we'll head to the bench and take a peek at these heads. All right, there we have it, and we're down to a short block. Now there's a couple things to note here, especially if you're not too familiar with the Italians, specifically the fact that this is a V8 with a flat plane crankshaft. Designating the way the crank throws are arranged, you can see that this is cylinder 4, cylinder 1. Both pistons are at top dead center, and they are basically synchronized, meaning they move up and down in their cycles the exact same time, although they're on different strokes. See cylinders 2 and 3, same thing. So these pistons are at top dead center, those two pistons are at bottom dead center. Again, different strokes. If I take you over to bank 2, you'll see that they're all at the midpoint and they're all equal. So it's very different than, say, your American domestic V8. And that's why these have that real high pitch, high RPM sound to them and not that big rumbly V8 sound. Kind of like they're a lot smoother, and this is why. It's because the firing pulses are much more even on these as opposed to a cross-plane crankshaft. Now you'll notice that these engines are pretty robust, pretty well built. So it's an aluminum block. It has factory steel liners in it, forged pistons from the factory. This engine actually happens to have titanium connecting rods, factory studs, and I mean, it's a dry sump oiling system. So this is all definitely race car territory parts. Definitely not common to be on a street going car, especially considering that these debuted in 1995. However, let's go to the bench because this is something I always kind of like to nerd out on. Now, I've done this throughout my entire career when I worked at BMW and Ferrari, and I've always enjoyed checking out the intake ports of different heads. Hot rodder in me loves doing it because you always, want to make more power out of your engine, get better performance. So I always like to scope and see what these OE manufacturers are doing in terms of ports. I'll get you a light here to show you, but these ports, see if I can get it just right. There we go. If you get down there, you can see this is our intake ports, and you can see essentially all of the backside of the valve on all three. It's a little hard to get our light. There we go. There's essentially no turn in that port. It is just a straight shot from the throttle bodies right to the backside of the valves. Definitely very extreme and radical. But that's how this thing screams, 8,500 RPM, and that's how it makes so much horsepower per liter. Again, this is only a 3.5 liter engine, so 213 cubic inches, 375 horsepower. So that's how they do it. But you can see here the configuration. We got 3 intake valves across and just our standard exhaust valves. Really small, shallow combustion chamber. And I was kind of mentioning it earlier on the packaging of these heads. Everything's super tight. You can see that it's really on the intake side. Those valves are crammed in there. There's barely any journal for our camshaft there. So the 3 valves are spark plugs, and this head's only about 8 inches wide. It's very small. So it's impressive that they crammed all that in there. I guess the downside is very hidden nuts for our head studs, but it's a small footprint, small cylinder head. Heck, it's a small engine, but pretty cool piece of engineering. Makes a lot of power. Sounds absolutely amazing. Again, 355s for all these reasons. All the cool engineering, the awesome ports in the heads, independent throttle bodies, the exhaust sound, the beautiful looks of the car, just the way they drive. These things are one of my staples. One of my all-time favorite Ferraris. I just can't tell you guys enough how much I love these cars. They're small, they're nimble, they handle good. I mean, I'll go on forever about these things. They're really good, trust me. So, the heads, we need to get those packaged up, shipped off to our machine shop, and then I think why those are out, I'll take the time, and I need to get the deck surface cleaned. You can see a lot of the head gasket material got stuck on there, so I got to get all that cleaned up and ready for our new gaskets. Clean up the threads of our studs. A lot of miscellaneous things. Needs a front crank seal put into it. Really, I have a lot of work to do. I still have the other repairs the customers approved. Need to do axle boots. I got to reseal the transmission. There's some other items on the car we need to address. So we got plenty more work ahead of us. But for now, we got this to a point to where we can get the head sent off. Well, safe to say, this is not the video I was planning on making. I initially planned on this video taking you all the way through the cam belt service, so I was going to basically get the engine torn down, run our pre-cam timing checks, get the cam belts off, and then run you guys through the procedure of installing the cam belts, and most importantly, degreeing the camshafts in. Now, it's unfortunate the situation we found ourselves in, finding those bad valve guides. We had a lot of little clues along the way, but it really took us, a little bit further down the road than I wanted to add all those clues up and really just figure out that, yep, these valve guides are starting to go and this car needs more repairs than we initially planned. Fortunately, the customer is good about it and he's given us the opportunity to move forward and get that taken care of. So where does that leave us here? We need to get the heads sent off to my machine shop, so they're going to be down for 2, 3, 4 weeks while they're getting machined. I'm hoping it's only just a valve job, but I'm afraid my gut tells me it's probably going to need guides as well. But what are we going to do in the meantime? Like I mentioned, I have a lot of cleanup to do on this engine. I have those CV axles to do. I need to reseal the gearbox, as we've mentioned. I'm really not sure if I'm going to cover that in another video or not. I'm really undecided, but I have a lot of prep to do. I need to clean all the parts up that I've taken off, replace all the gasket seals, and just get everything prepped and ready for reassembly. My plan, once the heads come back, there will be a dedicated video on that. We're going to reinstall the cylinder heads, get our valve train back in, the camshafts back in, and then as promised in great detail, I'm going to run you through the procedure on getting the cam belts on, tensioned, and our camshafts degreed. So with that being said, guys, I think that's going to be it for this video. I appreciate your support. If you enjoyed the video, be sure to drop a comment below, like the video, share it with your friend. Thanks for watching, and as always, we'll see you on the next one.